Series circuits calculating voltage, resistance, and current. When circuits are connected in series, the current through each resistor and the total current are equal. The total resistance of the circuit is equal to the sum of the individual resistances, and the total voltage is equal to the sum of the individual voltage drops across each resistor. Ohm's law states that the current is equal to the voltage divided by the resistance. This equation can be used to determine total current, resistance, and voltage in a circuit, and it can be used to determine current, resistance, and voltage across individual resistors. Given that the total voltage is 9 volts and the current is 0.5 amps across resistor 2, and the resistance across resistor 1 is 3 ohms, resistor 2 is 10 ohms, and resistor 3 is 3 ohms, calculate the voltage and current for each resistor. You know that the current is 0.5 amps across resistor 2. Circuits in series always have the same current through each resistor, so the current for resistor 1 and resistor 3 is also 0.5 amps. The total resistance is 0.5 also. We know the total voltage is 9 volts, and we also know the resistance across each resistor, and can therefore fill in some more blanks in our table. By adding the resistance of each resistor, we are able to determine a total resistance. 3 plus 10 plus 5 gives a total resistance of 18 ohms. We now know the current and resistance of each resistor in our circuit, which means we have 2 of the 3 variables in Ohm's law. By plugging the current and resistance into the formula, we can determine the voltage across each resistor. For resistor 1, we know that the voltage, E, divided by the resistance of 3 ohms, yields a current of 0.5 amps. Rearranging our equation to read E equals 1, or current times resistance, we get E equals 0.5 times 3. Therefore, E equals 1.5. We follow the same process for each resistor to get a voltage of 5 for resistor 2 and 2.5 for resistor 3. Our table is now complete. Always double check your work. If you calculated voltage and resistance correctly, the total voltage for the circuit should equal the sum of all 3 resistors. Likewise, the total resistance of the circuit should equal the sum of the resistance of all 3 resistors. In a series circuit, the total current and the current across each resistor is the same.